So this is the Moog Matriarch. This is 4 oscillator, paraphonic semi-modular analog synthesizer. So I'm not going to go through every single thing that this can do, because I think there's already plenty of videos out there that give you all of that information. What I'm going to do is try to talk about one specific thing that I think makes this a really usable and fun semi-modular synthesizer to patch with. And that thing is not the oscillators, it's not the filters, it's not the envelope generators, it's not the stereo delay. It's the utility section. And what I'm going to hopefully do is give you some demonstrations of using these utilities and why having these sort of utilities in a semi-modular makes it actually a joy to patch with and actually makes it usable. A lot of semi-modular synthesizers don't have any of these kind of utility modules in them. And when you're trying to create things like FM, ring modulators, things like that, you simply cannot do that without attenuators or mults or VCAs. And as these are inverting attenuators with the CV input, that makes them a bipolar VCA. So yeah, let's go through some patches and hopefully I'll give you an idea of what this synthesizer can do, and also in a kind of wider context why semi-modulars need attenuators and attenuverters and VCAs. So let's just have a look at the attenuators, or this utility section, first of all, just to kind of explain these, because it will make the rest of the video easier. So what is an attenuator? An attenuator is simply, you can take a signal input and attenuate or turn down the range of that input. Now, these are actually inverting attenuators or attenuverters, so they can adjust the polarity of the signal as well. So in its most basic form, I can take a signal input. So in this case, I'll take an envelope, and just to demonstrate, I'll just take that output into the pitch input of my oscillator. We're just listening to the one oscillator here, so you can hear, obviously, because I have this there's my envelope, and I can change the depth of that, and I can also make it a negative envelope. So fairly useful for that. Now, what's nice about these attenuators or inverting attenuators is that they have a CV input as well. So we can take one signal input and we can use another CV signal to control either the polarity, depending on the CV input, or the depth. So if I take, for instance, a different oscillator, go into the input here, and then the output of that oscillator, that attenuator, into the pitch input, or I'll just go into the linear FM actually. So if we listen to that, so this is now controlling the depth of FM modulation onto the first oscillator from the second oscillator. So obviously very little. Now if I take an envelope as the CV input, then this is only going to be a positive. The envelope is only ever going to be positive, so I'll make a really short envelope here. So you can hear that a little bit of FM, and then it dies away when the envelope dies away. Now I can go negative, but now I'm going to be positively affecting this signal from here. So if So anyway, you get the idea. You can use one CV to control the level of something else, and obviously that doesn't have to be audio as it is in this case. And also it depends on what CV input we have here. If we have a bipolar CV input, like an LFO, then this is, if we have this in the middle, this is going to go from negative to positive. So again, we'll just set that same patch up again. So now we're going from positive to negative, negative to positive. So anyway, you get the idea of why these are so useful, because it allows us to control the level of one thing with another thing, or the polarity of another thing with another thing. The other things that we have in these utilities is simple kind of passive mults. So we can put one signal in and get 3 repetitions of that signal. And then on the other side, we have another utility section, and we also have like a simple LFO with just a triangle wave and a square output. So yeah, let's jump into some patches and see what we can make out of these. So let's talk about this patch. We've got this kind of FM thing. And this is to kind of demonstrate again these utilities, the bipolar VCAs, and how much of a difference they make in the patching. Or they make you able to patch things like this. So we're actually only listening to one oscillator at the moment. In that kind of jam section I did bring in the others, but we're in single voice mode, so it's just monophonic. And we have oscillator number 2 coming into this attenuator here, and then the output of that is going into the linear FM of oscillator number 1. Now this is also going through the other attenuator just to give us more range. So if I was to take that out and we just go straight into here, it can get pretty wild. We're also CVing the depth of this FM modulation with the filter envelope here. So so what I did was take the output, go through another attenuator, and then we've just got a little bit more control. And then that also allows me to then CV the depth again with another modulation. So what I did when I started the sequence there is I took the output of the modulation here, which is on a stepped CV source. That's going through this other attenuator to the mult and then coming back in here. It's malted because it's going other places, and this just gives me a little bit more, again, more range, or the ability to turn this up and down. can change the wave here. Things like that. And obviously changing the envelope shape would change how much FM modulation is going on. Again, changing the waveform of the modulator, which is oscillator number 2 here, and my carrier, oscillator number 1. So we're still just listening to one oscillator here. Also brought in the filter at some point. And then the reason we have this 4th oscillator, which is being synced to number 3, which is an interval, but this is getting this step random voltage as well. So if we get it into the right range, so this is oscillator number 4. And then oscillator number 3. And bring into that FM voice again. CV modulation or LFO modulation here of the filter. But anyway, yeah, that kind of demonstrates a bit of using these attenuators to create FM patches. So let's just talk through this patch briefly. What we've done is create a ring modulator by using these attenuators. The noise here is no longer noise. We have our ring modulator coming into the input here. So how we've created this ring modulator is taken the 2 wave outputs from oscillator number 1 and 2 and used them into the attenuator. So this is what you heard in the... So obviously you can hear there's obviously filtering and effects going on, so I'll just zero all that out. So this is the ring modulator. So what we're actually doing is taking the two outputs from the two oscillators. One is going into the input of the VCA and the other is going to the CV input. So as this is a bipolar VCA, then we are essentially doing amplitude modulation, but bipolar amplitude modulation. So this is what gives us the ring modulator. So for this patch we're using some of the connections around the back. On the back here we have plenty of connection, Eurorack kind of compatible modular connections. So we're using velocity and aftertouch to create more kind of FM tones with filters. So the filters are at full resonance, we're in parallel, so high pass, low pass, parallel. So if I take out the oscillators completely, so that's now just the filter. We're using the modulation wheel, so we have an output for that. So this is essentially now an offset. We're using that to control the depth of velocity modulation of the oscillators. The velocity comes into this attenuator down here, and then the modulation comes into the CV input. The output of the velocity then goes back into the utility up here, which is split, and then goes to the two CV inputs on the filters. So it just gives us a really depth of control. So we can have no FM on the filter or very little, and then introduce that up, and then the aftertouch is coming in to this utility here, so splitting it, and then that's going to the pitch of the two modulating oscillators, but it's also going to the envelope amount of the filter. So as we push the aftertouch we get a pitch modulation of the oscillators, but also we raise the filter cutoff because we're using that to control the envelope amount, so it's going to positively affect the envelope amount. So yeah, I hope you've enjoyed this look at the Moog Matriarch, and also kind of learned something about how to use attenuators, attenuverters, bipolar VCAs, and why these things are important when we're patching.